All right, here we go with the Unit 6 review. Let's go ahead and get this thing going. So here we go. The rate of growth. The rate of growth is the thing that makes the inside bigger than or smaller than 1, and so that would be the letter R. The initial amount is the little letter A. The number of time periods is T, and the amount will be that day of T. Which one is the graph of that? So let's go ahead and graph it ourselves. Don't forget how to readjust that log when you type this in. So this is the same thing as saying log x divide by log 3. All right? So that's the log base 3 of x. This is how you rewrite it in your calculator. So then we add 2, and that should be our picture, and that looks like A. So things, that looks ridiculous, that looks ridiculous, that one's not even close. A is the only thing that looks somewhat close. Write this in exponential form. Okay, so the way to get rid of an ln is to take it to an e power. So whatever I do to one side, I take it to the other. So this is going to be 1 over x is equal to e to the 8. Solve this. So I'm going to get this 4x all by itself. So I'm going to minus 5. That'll get rid of the 5. But then I have to get rid of the negative. Okay, so I'll have some stuff, and then I'm going to have to divide by -1. So that division of -1. So this should isolate my 4 to the x. So let's go ahead and do those things. So we have -65 minus 5, and then divide by -65 minus 5 divide by -1. Okay, so now I'm chilling with 70. So again, I'll kind of explain a little bit closer what the heck I just did. All right, so I'm trying to get this 4 to the x all by itself. So I subtract 5 from both sides. There we go. And so, yes, it leaves me with this 4 to the x, but it leaves me with an outside negative as well. All right, so I don't want that outside negative. So I need to get rid of that outside negative. So what I do is I divide by -1. So if I divide by -1, it gets rid of the negative. But whatever I do to one side, I do to the other. And so 4 to the x, negative divided by negative is positive, so this is 70. All right. So now I'm chilling right here. All right, now I have this. So what I do when I have an exponent just on one side is I write this as a log. So this is log base 4. Okay. Then everything switches sides. So 70 and x. Okay, and then we just got done doing this. We know how to type this into our calculator. This is log 70 over log 4. So here we go to our calculator, log 70, log 4. 3.08. That's what I'm supposed to do. 3.08. Oh, I'm sorry, that's 3.06. I can't read my board. I'm sorry. 3.06. Okay, here I have a singular log all in, singular log all in, so I go ahead and get rid of the logs. Subtract by 2. It's all good. Okay, so I noticed that these are all additions, so that implies, so if I have like log A plus log B, that's a singular log of A times B. All right, so that's singular log of A times B. So as a singular log, this inside would be 36. Next one would be 36, 36, whatever 18 times 18 is, and so 36. So this one's good, this one's good, this one's good, this one's good, and I don't know what 18 times 18 is. I know it's not 36. Yeah, it's 2, yeah, whatever. That one's not right. Okay, multiplication is addition of the exponents. So the exponents are 3x, 1, and x plus 1. Okay. So these bases are the same. All I have to do is do the mathematics of the numerators. So this is 4x plus 2, 2x plus 3. I'll just write it into the next problem. So subtract 2x, subtract 2. So if you get those bases to be the same, it's all good. Okay. Notice how that middle 5 has an exponent of 1. You can't see it, but it has an exponent of 1. Okay, graph. Okay, so again, go to your graph. And so that's log x divided by log 3. Log x divided by log 3. Winner, winner, chicken dinner is A. A. Yeah. Okay, A is the initial amount, R is the rate, T is the time. So let's take a look here. Okay, so population 2000 is 6.8. So the initial amount is 6.08, and a rate of increase of 1.26%, which is the same thing as saying 0.0126. So what is the equation? So that means the world population is the initial amount, and then 1 plus that, so that would be 1.0126 T. At that rate, what would it be in 2020? So 2020 implies that T is equal to 20. So the amount when T is equal to 20 is whatever the calculator says it is. 7.81. Okay, log. This is an x plus 0, so that implies that the asymptote would be is at x is equal to 0. But other than that, let's go ahead and graph it, take a look at some of the stuff. I think this is actually the graph. Log of x divided by log of 3, yeah. All right, so the intercept is right here. That's at 1, 0. It's the only axis that it crosses, and it happens to be at 1, 0. The domain is the left and the right. So the left that this will go is 0. The right this will go is forever. All right, so this is also known as x is greater than 0. The range, this goes down forever and up forever. So this is negative infinity to infinity, or in other words, all real numbers. Solve for x. Okay, so what I want to do is I want to get a singular log over here. Subtraction implies division. So this is going to be log 3 of x divided by 7. See, log 5, not log 3. Doesn't really matter, it's going to go away right now anyways. All right, so now when I have a singular log equal to a singular log, the logs cancel out. So that leaves me with x over 7 is equal to 3 over 7. So it doesn't really take a rocket scientist to identify that x is going to be equal to 3. Next is 2 to the x. Okay. So what we can do is we can kind of take a look here because all of these look somewhat the same. So my advice is to take a look at some of these points where it looks a little bit, where does the picture look different from each other? And I'm kind of thinking that when x is equal to 2, you'll be able to tell some. So when x is equal to 2, so if I plug in the number 2 here, that's equal to 4. So when I make my x 2, my y should be equal to 4. Let's take a look at which picture has a point at 2, 4. This one doesn't. That one's way off the map. That doesn't work. 2, 4. That one looks pretty decent right there. 2, 4. Heck yeah. 2, 4. No, that one's way off the line. And this last one is probably the worst of them all, right? That one's way off. So the only one that is really kind of on the line is that B. So it has to be on the graph. Solve. Okay, what I'm going to do is I'm going to get the 6 to the x minus 3 all by itself. I'm looking to get the 6x minus 3 all by itself. So that means I need to get rid of 8. It's multiplying, so I have to divide. So now I have 6 to the x minus 3 is equal to 12. Okay, when I have exponents on one side, I'm going to rewrite this as a log. So this is log base 6. Log base 6. The base is the base. Everything switches sides. So 12 and then x minus 3. All right, log base 6 of 12. Let's use our calculator to figure out what the heck that is. So that would be log 12 over log 6. So that comes out to be 1.38685, something like that. Is equal to x minus 3. So if I need to solve for x, I obviously have to add 3. So adding 3 would be 4.2 decimal places 39. Okay. Growth and decay is determined by this. Okay, if it's bigger than the number 1, that's growth. Okay, if it's less than the number 1, then that means it's decay. How far it is away from that 1 is the percentage. It's the rate. Okay, so I see that this is decay. Okay, how much away from the number 1 is this? So let's take a look here. 1 minus 0.92 says that it's 0.8 away. Okay, so how far is it away from the number 1? 0.8, which implies 8%. Move the decimal 2 places. The initial amount is always that outside number. Don't mess with it. It's always that outside number, and that's 11. Okay, so we have the thing isolated, good to go. So when it's only on one side, I'm going to write this as a log. So log base 9. Okay, things switch sides, so the 66 goes left and the 2x minus 1 goes right. Let's plug that log into our calculator. So that's log 66 divided by log 9. So that's 1.9068. All right, so I'm going to solve for x. So the first thing I do is I add 1. And so that's going to be 2.9068. And then I divide by 2. And that will leave me whatever that is, divided by 2. All right, so here we go. So from my initial answer, I need to add 1 and then divide by 2. There it is. 2 decimal places, that'd be 1.45. Solve the equation. Get everything on the inside of that log. All right, so 7 is directly touching. That's going to go up as the exponent of that x. So, no, I know what I'm going to do. I'm going to simplify the process. I'm going to divide by 7. So log x is 3. All right, this is a base of 10, so I'm going to rewrite it. So this is 10, and then everything switches sides. The third is equal to x. So x is equal to 1,000. Okay, variable on one side, write it as a log. So log base 5. Whew. All right. Use the calculator. So that is 2.9798. Divide by 3. Two decimal places is 0.99. Evaluate the following using a calculator. All right. Man, this is just, it almost seems like it's a trick question. So that is equal to 2.32. Evaluate the following without using a calculator. Okay, so this is equal to x. So this is base 13, and then everything switches sides. So x comes over 169, and then this would be to the second power. 13 to the second power is equal to 169. Okay, graph this. Okay, this is the indicator that that is going to be your asymptote. That touches the y-axis, so our asymptote is y is equal to -4. Let's take a look at the other stuff so we can answer the other questions. Let's go to a graph. And so this is going to be 3 1/2 to the x minus 4. Oh, oops, minus 4. There it is. Okay, the intercept. I'm assuming they're interested in the y-intercept, not the x-intercept. So their intercept is at 0, -1. That's what I very much assume that they're after. Domain, it'll go left and right. It's all good. And the range, it has a bottom floor at -4, but it will go up forever. So this is y is greater than -4. That's it. That is all.